roots and zeros of Module 3, we're going to take a look at the fundamental theorem of algebra. And basically that helps us distinguish between when do we use the word zero, when do we use the word root or solution, or a factor. And basically we use the word zero when we're talking about the function itself. So when we're talking about p of x, a function equals an equation, we would say -6 and 3 are zeros of the function. We say roots when we take what that equation equals, that expression when it equals 0, we say those solutions are roots. And then factors is when we take that polynomial or that expression, quadratic expression, and find the factors by factoring it. Right, and then we can say the function, when we go back to the function again, we can say these are intercepts, right, when I set them as points. Okay, and that is the fundamental theorem of algebra. The other big thing about the fundamental theorem of algebra is whatever the degree is, that's how many zeros we have, or at least that many. So if I have a degree of 3, that means I have 3 roots. Now, some of those roots might be complex solutions, or they might be real roots, they might be complex. Degree of 4, so there's 4. Degree of 5, so there's 5. And the way to figure out if they're positive or negative or imaginary solutions is we can do Descartes' rule of signs, which basically tells us how many positive answers we have, how many negative answers we have, and how many could be imaginary. It gives us all the different possibilities of different combinations of solutions. So in this first example, we're going to determine the number and type of roots. So here's our polynomial, and so we can see that it is degree of 4, so that means there should be 4 roots. And now we need to know what type, how many are real and how many are imaginary. We can do that by solving this. So we can see that there's an x in both of these, so we can factor out actually an x squared. We can factor out an x squared, so we're left with x squared plus 49. And this is set equal to 0, so this is also set equal to 0. And when I'm multiplying two things and the answer is 0, I can set them both equal to 0. So then I solve this, square root both sides, square root of 0 is just 0, so x equals 0. So that's actually twice, because squared means I have 2 solutions. So actually x equals 0 comes about twice. So there's 2 solutions. 2 real solutions. Then when I solve this one, I notice when I subtract 49, I get a -49, and when I square root a negative, it becomes plus or minus I square root 49, which indeed equals plus or minus 7I. So there's 2 imaginary solutions or complex solutions, and here's our 2 real solutions. So 4 of them total, and then the types are both real and imaginary.